the Research Center for Renewable Energies in Algeria. He earned his Ph.D. in 2016 from the University of Beira, Algeria, and later he pursued advanced studies in mechanics and engineering at Southwest Jiaoning University in China. His research focused on thermofluid, hydraulics, and pneumatics. Dr. Chekifi, thank you for accepting our invitation, and you can start, please.
First of all, thank you very much, Dr. Ben Moussa Amin, and all your colleagues, laboratory members, your manager. Thank you very much for this opportunity, giving us the opportunity to share our work and our institution, our institute, our unit of research. Okay, and this is online. It's a very good idea. I hope to transfer this idea to our research unit. Maybe we can also adopt these activities monthly. And I hope I will visit you to attend another conference or event you are organizing. So in this talk, I want to present the solar cell as a sustainable water distillation solution, which allow us to enhance the productivity with date and olive kernels as a heat material storage. So this presentations include the introduction. I will introduce our research institute. Then I will talk about the solar cells. I will give you some principles and definition. Then I will present our case study, the hemispherical solar cells, and I will conclude by conclusion and question answer. As introduction, our research institute is national research center. We have the administration. The main administration is located in the capital of Algeria, CDER, which is the Center of Development of Renewable Energy. And our research unit is located in Ghardaia city, in the middle or in the north of the south of Algeria. It's in the limit of the south of Algeria. It is a public institution responsible of conducting research on energetic systems. The main topics are solar, geothermal, wind, and biomass energy. Our research unit is renewable, unit of research applied in renewable energies. In this research unit in Ghardaia, we have two main divisions. The first one is application of renewable energies in arid and semi-arid environments. In the first division, we have 4 teams of research. The first one is hydrogen technology. The second one is solar pumping. The third one is energy system for agriculture. And the fourth is solar agriculture and bioclimate. In the second division, we have also 4 teams. The division is mini solar power station and SPS, which is composed of 4 research teams. The first one is electrical control, many photovoltaic plants. The third one is mini thermodynamic centrals, and the fourth one, which is our research team, a hybrid energetic system. And in this picture, you can see some prototypes we realized in our research unit, like cooker using dish, parabolic dish, using concentrating dish, and we have a platform for agriculture application. It is available for students. We have some solar panels, and like we can see also heater, water heater, and PPC systems, parabolic collector. Our previous project is a small solar tower collector. This is the first small plant in Algeria. Solar tower collector is a group of mirrors, 17 mirrors, 1 centimeter square for the surface of each mirror. These mirrors are reflecting solar ray into forward the receiver tube, and inside the receiver tube we have a heat transfer fluid, which allows to increase the temperature of the heat transfer fluid in the receiver tube, and the heat transfer fluid will transfer this energy or heat to the turbine, steam turbine, and which will allow us to produce electricity. This is our previous project. And also we can see here in this picture a top view of the small solar tower in this research unit. We finalized this construction of mirrors in 2021. Our current projects are using all of the solar water heating system using PVT photovoltaic with thermal aspects to heat water, and we also focus on investigating the solar cell performance improvement using solar energy to produce distillate and clean water. The third one is photovoltaic thermal hybrid solar collector, where we produce electricity and heat energy for heating water or heating rooms. In our research team, we have submitted two international projects to exchange experience and to have a source of the funding. And now we are waiting for the decision of the research project. We hope to have a good and positive response. We are collaborating with the Research and Technology Center for Energy with Professor Salwa and Professor Rima. And we are also collaborating with Zhangzhou Research Institute in Heat, China, Professor Xingzhu. And we are collaborating also with Professor Eugenia and Professor Paolo in Italy within the lab thermal engineering, applied thermal engineering in the University of Bologna. And we are also collaborating with Fraunhofer Institute in Freiburg city in Germany. And also, of course, I hope to have a good response from Dr. Amin to collaborate in the international project right now. Even in, you can also proceed to numerical. I know you are focusing numerical simulation, but you also can combine numerical and experimental work in some task in our research team or your lab. Okay, in our research center, we are organizing some events like conference, international conference, national one, the day of studies, open days for students presenting our prototype and our research, some workshop and many other activities to allow people and students and visitors to have some idea on what we are doing. And by the way, in the next October, we have another conference, international symposium on renewable energies. It is in 15 and 16 October. So you are also welcome. You can submit your paper in this to this conference, and I think the accepted papers will be published in the thoroughly proceedings. Okay, let's talk about the solar cell. So the principle of the solar cell is summarized into main phenomena. The first one is evaporation, and the second one is condensation, which allow us to have clean water. Okay, the solar cell is composed of basin. It can be in steel or another material with insulation, of course, to minimize the loss of the heat. So it can be painted in black to absorb more heat and to keep a high temperature for the clean water. The basin is including brackish water or saline water. The top we have a glass cover which is transparent and which can allow to receive and transfer the heat from the solar to the clean water, to the brackish water. So the sunlight heats the contaminated water in a sealed basin, turning it into vapor. When the water temperature is increased, it will become a vapor, and the impurities, salt and microbes, and all the solid particles are left behind. This is the first part of the solar cell principle. The second one is the condensation. The vapor rise and condense on a cooler, sloped and clean the transparent surface. Then the clean water droplet will be formed and trickle down into a collection trough. Okay? Then the clean water will be collected separately in external pots. There are two main categories of the solar cell. We have a passive solar cell and active solar cell. In passive solar cell, water is purified through natural process, heating, evaporation, and condensation without mechanical part or external energy. Okay, so there is no mechanical part, no external energy in passive solar cell. In this passive one, we have three categories. Depending on the design, you can find hemispherical, pyramid, tubular, and conical. And in the modification categories, you can find with solar cell with reflectors and with sponge. In solar passive solar cell with integration with other systems, you can find passive combined with thermal storage, or solar cell combined with hybrid photovoltaic, or photovoltaic with thermal aspect, and we can combine also passive solar cell with concentrating solar power, CSP. In this slide, I show you some real passive solar cell. You can see aqua-made solar cell, which is applied in surface sea. You can transfer the surface, the water sea, which is very sunny water, into clean water. You find also spherical form, and solar cell we can combine with reflectors, and we also can find in passive solar cell conical solar cell, and we have many other kinds. This is just a few examples. In the active solar cell, extra power or mechanical part help them to work better. These they might use pumps, fans, or heaters, which make them more effective but little harder to manage. These are great for places that need more clean water. Okay, in the active solar cell we have external power energy or some mechanical parts. We find as external power we can add parabolic uh, parabolic throw collector or dish collector. Also, we can add photovoltaic panels, produce electricity, for example, for pumps and for external power. And we can also use hybrid system for to produce electricity or require or to some machines in the active solar cell. And in this slide, I show some real active one. Yeah. The first is solar cell with photovoltaic, and the second is the hybrid using photovoltaic and CSP. The third one is using the glass cooling and also water heater. The fourth one is solar cell with parabolic throw collector. The solar cell performance enhancement. So, if we want to increase the performance of solar cell, so we need to increase the performance of evaporation or the condensation. To increase the evaporation performance, we need the thermal storage, nanoparticles. We can use also photovoltaic and heat exchanger, which will allow us to increase the temperature of the brackish water in the basin. So if the temperature, if we reach to increase more the temperature of water, so we will have more evaporation amount. So the performance will be increased. The same for to boost condensation. We can use the cover cooling, so we can cool the glass cover, and we can use external condensation, or we can use also nanoparticles, and we can use air injection, which will improve the condensation amount. In our prototype, we focus the investigation of the hemispherical solar cell. It is with the form of like hemisphere, and we are simply and handily way we are simply testing how added materials can boost its performance, especially in desert region where clean water is hard to find. And also in our region, we have many trees of olive and date trees, so the kernels are available locally, for example, not expensive. So why not use these materials to increase the performance of our solar cell? So HSSOE is a hemispherical solar cell with olive kernels, like we can see here, and this is the kernels of date. The third one is hemispherical solar cell, okay, with olive kernel. In the weather condition, we saw how humidity and wind speed can impact our prototype performance. Like for example, the humidity and wind are important for water evaporation and condensation. Lower humidity helps evaporation, and olive kernels keep the basin warmer with a high temperature, boosting it, and a high speed of wind cools the glass cover, of course, and make condensation with more amount. Our hemispherical solar cell works best in dry, long wind days, and olive kernels hold heat better. This figure shows the ambient temperature and solar radiation, which are key for solar cells to work well. The strong sun rise both temperature and radiation to a peak around midday, providing enough heat for water to evaporate, then decrease until sundown, allowing after sundown, allowing cooler condition for condensation. This change creates ideal condition for evaporation and condensation, setting the stage for our test. Also, the brackish water and the basin temperature rise during the day, which reach a peak and then fall as the day ends. A warmer basin also helps the water turn into vapor faster. So adding olive and the kernels make the basin even warmer and more heat. Olive kernels keep the water between 5 and 6 degrees hotter than the date kernel during the sunny hours. The collected volume in these 3 days, 15, 16, and 17 July, this experimental work has been carried last year. So in these 3 days, it is clear that the olive in the middle, olive and date kernels helps make more clean water each day, and the solar cell with olive kernels give better results than the date kernels, which is due to the ability for the olive to store and realize heat more effectively compared to the date. This is also due to the heat capacity of olive, which is bigger than the CP of date kernels. In this slide, I show how well the conventional hemispherical cell and the solar cell with olive and with date kernels performed on July 6 and 7. It shows that adding olive and date boosts their efficiency. For example, the solar cell with olive gets up to 13.54% better than the date kernels, which is only 10.87. Also, both of with the date and olive are better than, of course, the conventional without any thermal storage. This helps us understand how well they store heat when the sun is changed throughout the day. So, for example, when the day is cloudy, the solar cell with kernels will keep the temperature of water heater than the solar cell without material storage. That's why we are proceeding this material of storing temperature. Okay, the solar cell cost we realize for utility configuration. The manufacturing costs include the tube, button, hemispherical glass, and heat source material. These materials are all of them are available here in our city. All these materials are paid with local currency. Then we exchange the total price from BZD to the USD. So the hemispherical solar cell with dates is about 25.62. All of them are around 25. So this small difference is due to the price of the date kernels and the olive kernels. As conclusion, our case index include heat storage materials significantly enhance solar cell performance by improving heat retention and evaporation rate. Olive kernels resulted in higher brackish water temperature than date kernels, and olive kernels maintained about 5 or 6 degrees Celsius higher temperature during peak solar hours, enhancing evaporation and distillation. Daily productivity reached 8 kilogram per meter square per day. For olive kernels, efficiency increase of 13.454% versus 6.66 kilogram per meter square per day. For the date kernels, the efficiency increase of 10.87%. And superior thermal properties, density and specific heat of olive kernels enable sustained energy storage and real life. And the natural materials like olive and date kernels are shown to be eco-friendly and cost-effective alternative to synthetic thermal enhancer in solar cells. And thank you very much for your attention. And if you have any question, no problem. I'm here.
Thank you so much, Dr. Tawfiq, for your insightful presentation. I really appreciate the time and the effort you put into your talk.
Thank you very much. You're welcome. Okay. Yes.